Without further ado, welcome to our third webinar for the Cherry Nutrition Winter Series. Today we've got two fantastic speakers, Edwina Murray from NEM and Dugald Close from Tasmanian Institute of Agriculture. And we're talking all things biologicals and growth hormones. So hopefully Edwina is going to run through some of the nutrient cycling and her work in microbiologicals. And then Dukes is going to talk about the presentation that he gave at the International Cherry Symposium, all about GA sprays and their impacts on Lapin cherries. So I'm going to pass on to Edwina now and stop sharing my screen. And so, like I mentioned, Edwina is from NEM, which is a microbiological company, and I will allow her to share her screen.
Okie dokie, just give me one moment. Is that all good?
Looks perfect. Thanks, Edwina.
Wonderful. Okay, so I'm happy, first of all, to be stopped at any time to answer questions, but yeah, just keep in mind that, you know, some of us want to eat dinner, so that's all cool. So I put my phone number on this first screen just in case there's things that you think about later or things that, you know, we don't have time to address today. So please feel free to contact me. And if I don't know, I'll find someone that can help you out. So yeah, it's an absolute pleasure to be here today. The cherry industry is seriously cool industry. So congratulations on doing something that, to be honest, is pretty hard. But 10 out of 10. So I wanted to start off today with a joke. And I went on to Google and said, what is a really cool joke about microbes? And many things came up. But one that was on point, but also took me back a little bit, was this your mama joke. And it was, your mama is like a microbe, she'll spread diseases. And I went, oofed. Right. That's, in some respects, absolutely correct in regards to microbes. But there are so many other things that microbes can do for you on your farm. And by the end of this presentation, I'm hoping that we can turn that your mama joke around to actually something a bit positive. So stick with me and we'll walk through it. So today, what I'd like to talk about is biologicals in general, just to start with. You know, what are the types and which ones?
Can I get your name?
I don't think so. I ran on to see that one.
Sorry, Nathan. I'll
Sorry.
just jump on mute there.
It's decided that this is
Peter, I'm not sure if you can.
Oh, there you go. No, it's all good.
Yeah.
Yeah.
There we go.
All good. Yes, so I'll start by talking about the types of biologicals, just talking in general, and which ones can influence nutrient uptake and cycling. And then secondly, we'll do a little bit of a more generalized look at the N and P cycles and the microbial roles. Jess was so lovely to have me on her podcast where we went into a little bit more detail. So I won't go into all the mechanisms or what I spoke about there, but just enough that we can have everyone sort of on board together. So yes, nutrient cycling and the processes and what's influenced by the biology in your orchard and how, and then biological mode of actions, which is something that is probably not widely spoken about, mostly because it's quite complicated. So I picked a few things here and there that I think hopefully will give value to you guys. And then there's a really great example that I pulled out of a academic paper that talks about the difference in systems in the phosphorus cycle with and without biology, and we'll have a look at that. And then to finish off, we'll have a chat about, how you can improve your biology if you're thinking about that and the future there. So, next slide. There you go. So, essentially speaking, biologicals is a massive area, and I think everyone here today can pretty much say, no matter where they go these days, it appears that everyone's got a biological, and it's something that seems to be a little bit of a key word that we just apply to stuff that we don't know what to do with. So basically, if you look at the APVMA, or if you also look at a few other classifications, biologicals fit within 4 categories, and that's microbials. So that's living microbes in some sort of formulation, or not necessarily. Extracts, so that's plant extracts, and also plant enzymes, things like that. So when you're thinking about your seaweed products and things like that, that would sit in that extracts bubble. Biochemicals, so they're sort of control agents or things that are more chemically based and are more traditional in their activity. And then lastly, we're looking at just a general other, where pretty much they throw everything else that they're not sure about. But a really good example of things in that area are, say, like predatory insects that you can release on your farm. And then all those 4 sit in those 3 categories at the bottom: biostimulants, biofertilizers, and biocontrols. So when we're talking about microbials, which is something I would like to focus on today, they pretty much sit in these 2 areas. We're talking about biostimulants and biofertilizers. There are microbial biocontrol agents, and some of them are here in Australia, but there's very little. So I'm not going to talk about that too much today, but if there are any questions around that, feel free to send them through. So the big ticket items on your farm, your nitrogen and your phosphorus. These are the stuff that pretty much we all know we've got to be putting them in, but tend to forget about the roles that microbes can play in those systems. So nitrogen as such, if we look at nitrogen fixing bacteria and things like rhizobia, it's sort of a free worker on your farm. It's taking nitrogen out of the atmosphere, and 78% of the Earth's atmosphere is nitrogen, and it converts it using certain processes and things like that into an available form for your crop. And so we need to remember and think about what's happening underneath our cherry trees, and whether or not planting a pasture or something like that has the capacity to use rhizobia means that we can get more nitrogen into that system. Secondly, the phosphorus cycle. So there's sort of 2 different pools of phosphorus in general. There's the organic and inorganic forms that sit in our soil. And I know we've all pretty much been putting on a lot of phosphorus over a lot of time, but not getting a lot of efficiency out of it. And what that generally comes down to is the microbial populations in the soil and their activity, because microbials have the capacity to produce things like organic acids and enzymes that can transfer those forms that plants can't reach to plant available forms. So these 2 are great examples of how microbes have kind of been around forever, fueling farming systems, and we've just kind of forgotten about them because there's other sources that are quicker and faster and seem to give that sort of boom bust effect. So The next slide is, I basically looked into all the different nutrient cycling processes that are noted in literature, but also just generally in nutrient management. And pretty much, except for physical weathering, which has a sad face because it's not, unfortunately for me, doesn't have microbials involved, but the rest of them, solubilization, mineralization, immobilization, which I put a yellow face there because it's a complicated relationship. Microbes will compete with plants for nutrients as well, but as soon as those microbes take up that nutrients as such, it is actually in some way safe, and it's sitting in that microbial cell. So when that dies, it becomes back available. So think about it's sort of like putting a deposit in the bank. You'll get that cash back later. And then oxidation and reduction reactions, absorption and deabsorption, and then finally leaching. And I know we don't really like to talk about losses of nutrients in the environment, but the fact is microbes do play a role in that. But what they also can do is build into that organic matter of soil or soil structure and then reduce the amount that is lost. So mechanisms of plant growth promoting bacteria or plant growth promoting microbes. It's pretty complicated. And if we had hours and hours, we could talk about them all, but I'm sure some of us want to go to bed. So that's not going to happen today. But I've selected a few that I think will give value to you guys as growers, and also simply put some of the mechanisms that, if you have the option to enhance, would be a really good thing for you guys. So that's siderophores, lactic enzymes and enzymes, and also looking at phosphate solubilization. So siderophores, essentially speaking, they're a molecule that's produced by microorganisms that scavenge iron. And essentially what they're doing, they're going through the soil and they're picking up the iron that sits as an iron Fe3+. So it's got 3 extra sort of electrons to play with. And what iron does is siderophores does due to that iron is they use that extra 1+. They use it for energy and internal processes as well. And they spit the iron back out as Fe2+. Now, Fe2+ is the exact form that plants need for iron. So there's sort of beautiful little mechanisms that's happening where it's a win-win situation for everyone involved, because the bacteria gets, that extra bit of 1+ energy, and then the plant is able to use that source of iron. And I know we often forget about iron as a source in our orchards, but what we need to remember is iron is absolutely essential for chlorophyll formation. So if you want efficient photosynthesis, you need to have iron. And to have good iron, if you're not supplementing it, then you need to have a good microbiome in your soil that's actively doing these things in the background. So next up, I'd like to talk about enzymes. So not all enzymes are the same, but basically an enzyme is something that can take one thing and transform it into another. We have enzymes inside our body that do exactly the same thing. But in the soil, a really good example is the phytase enzyme that some microbes can produce. Now, phytase enzymes, and so anything that ends in A's is an enzyme, breaks down phytate. And phytate is essentially the phosphorus portion of organic matter. So it goes in, takes the organic matter, and it breaks it down. It releases that organic P so that the plant can take it up. Secondly speaking, there are lytic enzymes, and a colleague of mine calls these the lit enzymes because they're pretty cool. And they do a whole lot of functions in a whole lot of different processes, but there's a few of them that are really efficient in breaking down things like cellulose, which, brings out those complex carbohydrates, or urease, which can be really important in the nitrogen cycle, and converting urea to things like more stable forms in the environment. And all of these enzymes, which microbes produce, will eventually have effect on your plant health. What we've got to remember as well is that microbes, they're not a slave. They've got their own thing that they want to be doing here. So to have a productive phytate or phytase enzyme working within your soil, you've got to have phytate. Phytate is organic matter. So microbes can't basically make a cake with no ingredients. They've got to have that stuff there to work with. But what they can do is, take the eggs and take the butter and take the flour and make a cake. And that cake is then used by the plant. So another really cool thing that microbes can do is they basically can make these transport systems within your soil. And when I say transport systems, there's a specific fungus that I'd like to talk about, mycorrhizae, that basically can latch onto the roots of your plant and then send out these extremely fine filaments or hyphae that can access the very tiny areas within soil aggregates and soil pores and pull out that moisture and pull out that nutrients for your plant. And then they also have the capacity to synthesize things like phytohormones, organic acids, and chelators. So they can do this sort of dual activity of going into places that the plant cannot get, taking the nutrients, transforming it, and then taking it back. And I think that's something that we need to think about all the time, is the transport systems in our soil. How are we getting the nutrient to the plant? It's all well and good to put it on, but we need to make sure it's accessible and it can be transferred to the plant when the plant needs it. One of the last slides that I have is this one today, and this comes from a paper that's very interesting, and if anyone wants to read it, I can supply the link, but it is very heavy. Essentially, on the left-hand side, you've got a farming system where they're just applying mineral P fertilizer. And on the right-hand side, they're applying mineral P fertilizer, and they're also applying biofertilizers with it. And what you can see is basically you've got an organic pool of phosphorus and an inorganic pool of phosphorus. And these are the things we were talking about before, that, some of them require breaking down by chemical mechanisms and others by enzymes and things like that. So it's a lot to take in this, but what I want to show you is that if you look at the right-hand side, the arrow going down with the 1 and the arrow going out with the 2, they're basically the loss pathways, and they're dramatically reduced compared to that of the right. sorry, the left. Additionally speaking, if you look at the organic pool is much bigger. And that's because it's consistently cycling because of these different microbes doing all the different nutrient solubility and mineralization, et cetera, et cetera. I know that the available pea pool looks smaller and it might be smaller, but it's more active. So it's things constantly moving out and moving back in. And that pretty much leads into that big arrow that's an 8, which leads up into the plant. So the plant has a more consistent nutrient source. And then lastly, what I would like to talk about is the inorganic pea pool, which is that star on the right-hand side. If you look at it in the system where there's just mineral P being put in, there's a lot of that P, which is that, number 4 arrow, that's just being locked up. It's not really being put back into the system, it's just being lost. But as soon as you put microbes in there and you increase that activity, yes, some's being locked up, correct, but it's also being put back in. And this is the whole idea around adding microbes or biologicals to your systems, is that it's not saying that it's going to fix everything overnight. It's not a urea, and I will absolutely stand by that. You're not going to walk out the next morning or the next day after a rain and go, oh my God, this is different. But what you will see over time is less of these sort of extreme nutrient boosts and then declines and then boosts. It's about creating a system that is just constantly sort of ticking along in the background, doing its own thing. And it means that you as a farmer don't have to think so much about, oh my God, my plant is flowering at the moment, I better put this. My plant's doing this at the moment, I better put this. It's about looking at that system going, okay, it's going along well. What are the little things here and there that I need to adjust just to supplement, rather than going big and then nothing and then big and then nothing. So to finish off, I want to just touch on nutrient cycling and how you can improve it. And one of the good points is pretty much consider your biology. What are you doing on your farm that's helping microbes? And what are you doing that's damaging them? And I'm not going to stand here today and say, do not use fungicides, do not use herbicides, do not use insecticides, because the fact is they play a role and they play a very important role. But it's all about looking in your toolbox and going, okay, when do I need to apply these things? And I have this analogy that I like to think of, is that a lot of the time in farming, if you look at how we treat diseases or insects, a lot of the time it's sort of would be the equivalent of giving people antibiotics all the time, hoping that they don't get sick, rather than thinking about, okay, let's give them some vitamin C. Let's make sure, their iron is good, they have good sleep. And then if they get sick, utilize those other stronger techniques. The second point I want to make is consider all your nutrients, macro and micro. Macros have been the main focus of farming for decades, and macros will produce you a piece of fruit, but they won't necessarily produce you something which is a resilient farming system. The micronutrients play a massive role in basically keeping everything in check. And if micro nutrients are a little bit too hard to think about in your nutrient management, you know what will do it? Microbes. Put them in there, let them go, and they'll sort of manage that in the background. point number 3 is organic amendments. If you want to improve your biology, you've got to feed them. They're just like livestock on a farm. You know, you're not going to get a return on your sheep if you stop giving them hay and they don't have any feed. So to have an active and, you know, serving microbiome, you've got to give them amendments from time to time. And lastly, if you think your functioning or biological functioning is slow on your farm, check it and re-inoculate if it's not functioning at its best. And the best way to do that is a really cool initiative that's come out internationally, and the Cotton Farming Association has picked up on it, is the Soil Your Underpants campaign. And if you can get yourself a pair of cotton underpants, 100% cotton, bury them in the ground for 6 weeks, and then pull them up, if they've degraded over time, it means that there is some biological activity in that soil. If they haven't done anything, it means that there is a serious deficiency in the microbial population in that soil. And from what we've been seeing from a lot of our research, resilient systems and resilient orchards have that medium to high biological function. So keep using that as a good check. I think it's a really good tool that's relatively cheap, and go from there. So to finish off, these are just some of our products, but I'm not here to necessarily say anything in particular about products, but just remember that there is more to your farm than what's above the ground. And I would really recommend that you utilize this time before, you know, we lose certain fertilizers and things like that, to try things out. See what you can do by enhancing the biology that's there, working for you for free. And lastly, what I'd like to say is a big thank you to Jess. I don't think she's got a massive thank you, but she's done an absolutely amazing job putting all these webinars together and the in-person sessions, because I've learned a lot and I hope you guys have too. So thank you, Jess. And I'll stop sharing now and I can take questions, or we can do that at the end, whatever suits.
There's some questions in the chat there.
Yeah, thank you.
Oh, sorry, I can't see it.
No, that's fine. We might have a 5-minute question time before we put Dukes on, but thanks, Edwina. That was a really interesting presentation, and I hope makes us, a couple in the room, think a little bit differently. I know the learning curve of trying to learn all the different fertilizers and everything, and now microbes and how they all interact is a bit of a learning curve. So really appreciate you stepping through the different cycles. But we have got a few questions. So what we might do is we'll spend 5 minutes here, guys, and if we don't get to your question after Dukes, we'll come back, or Edwina might be able to answer some in the chat as Dougal's presenting. But couple, Edwina, just around the study that you spoke about. We've got what type of biofertilizers were used in the study, and if you could provide the link. So I'll let you provide the link while Dougal's speaking, but do you know off the top of your head the biofertilizers that were used?
Don't off the top of my head. I know that there was some form of bacillus, but I will have to double check exactly. I don't want to make it up, but I will put that in the chat for everyone to have a look at when they would like. So sorry about that. I had all the other notes, but not that one. So
no worries. So how important do you consider the soil environment being before you put your microbes in? The soil environment needs to accommodate the microbes and foster their multiplication.
Absolutely. And this is a question again about the type of microbe. So some microbes require very, very specific conditions, and then other microbes are quite happily to function by themselves. But pretty much, Russell has knocked this on the head. If you don't have moisture, if you don't have food, these things are not going to survive. Like I said earlier, they're livestock. You've got to think about them like that. You're not going to put sheep in a paddock that's got no feed and no water. Luckily, in cherry orchard systems, there is the option to irrigate. And because the trees are there a lot of the time, we're not doing sort of an annual sowing and then ripping up and sowing and ripping up. So there is, generally speaking, a little bit of organic matter that's just naturally there. But in saying that, every year we take the cherries, we pick them and we take them off the farm. And that's the main purpose of a piece of fruit, is to give all the nutrients for that seed to live. So trees really put a lot of effort into those pieces of fruit. And afterwards probably need a little bit of love.
So with food, just a question, that's organic matter. So applying an organic matter source to the soil in terms of a mulch or a cover crop or something like that.
Yeah. And as everyone I'm sure is well aware of, there's, organic matter that will break down quickly and organic matter that's a little bit more available. What I would recommend if you're getting into this and you want a place to start, is start thinking about the organic matter supplements that are a little bit more available. So maybe chicken manure or things like that. Whereas your heavy mulches, which, quite full of those structured cellulase, they're going to take a bit more time. So you're not going to see an effect as quickly.
Perfect. And a couple of questions around the best time of year to apply biofertilizers and timing for re-inoculating.
Yep. So the cool thing about cherry trees is that, they go to sleep for a good portion of the year. So my recommendations for supplementing microbes into those systems is in the spring when they're starting to wake up. And also because it's a little bit warmer at that time, and microbes, just like people, we like it when the sun is out. So they'll replicate a bit quicker. There is also the option of supplementing microbes before the tree goes to sleep, so that when those dormancy processes start, there's support and nutrition there. But those would be the two times that I would look at. And we have done some work in young, which I'll probably present when I'm in young, which looks at applying nutrients at the start and the finish, and the different tissue test results that we've got from doing that.
Perfect. All right, we might get you, there's a couple of questions about the particular products, Edwina, in the chat, which I might get you to reply to in there.
Yep.
So we'll move on to Dugald Close, who is all the way from Tasmania. Thank you, Dukes, for coming on today. And I was lucky enough to hear Dugald present at the International Cherry Symposium in Washington. So this presentation's been vetted by our international researchers all around the world, but we're lucky enough to have Dukes today to be able to present on those findings for us as well. So thank you. And I think your mic's muted, Dukes.
There we go. Can you hear me now?
Yep, can hear you. Perfect.
Good, good. This is a nice thing about Zoom. I can be sitting in my office, got the slippers on, nice and comfy. Yes, welcome everyone from down south in Hobart. I was just sort of looking at the participant list, and I must say, other than Jess, who has to be here because it's part of her job, those of you that are listening to this for a second time really need to get more of a life and maybe get out a bit, do something a bit fun. Don't listen to me for a second time. Anyway, don't take life coaching from me either. All right, so on to the topic at hand. So we're 2 seasons into a research project. It's very focused on the major crops of economic importance in Tasmania. We've done the first season in the Derwent Valley and the second in the Huon Valley, and Ramondeep ran the first season field work and Alita the second season field work. And Nigel and I spend a lot of time in the office, sadly, in front of the computer, but that's the way, it's life. And here we've got, this is the joke I've used a few times, but Andrew Hall is our poster boy. The marketing folk went up to Jericho when Andrew was hosting some of our students, which he kindly does, and took this photo just before Andrew's Dalmatian took out the drone. So they got the footage just before the drone got destroyed, which caused a bit of excitement. But at the end of the day, they got the photos, so that was nice. Okay, so on with TR, we're a joint venture with state government. We're based at the University of Tasmania. We do research development and extension. Also teach undergrads. Okay, so this work we're doing is really sort of steered by an industry reference group. There was lots of questions outstanding around GA rates and timing for that matter. So whether you're looking at the export market or not, there's always a premium for size and firmness is expected. And particularly in export markets, the turgidity and the colour of the stem is an indicative of freshness. It's not always a true indication of freshness because the stems do dry out at a much faster rate than the fruit deteriorates in terms of quality, but nevertheless, that's what they use as a visual guide. So we know from lots of research, over many decades, in fact, that GA delays maturity. So it sets back the effects of ABA and ethylene. So there are other endogenous plant hormones that essentially ripen the fruit and speed up maturity. So GA works against those hormones in terms of its internal plant function. And GA is something we can easily and cheaply manufacture and spray on our trees. So the plants obviously produce GA internally. It increases vegetative growth, as all growers would attest to, by speeding up cell expansion. And it also has this hormonal effect of slowing down the effects of plant growth and development, essentially, like slowing down the maturity, I should say, not the growth. So GA can be used to delay maturity. That's why it's generally used. They can attain larger size in some studies. That's not always the case. It depends on the study. I think it depends a lot on crop load, depends on the variety and the growing context. If we're looking for late fruit, we can hold fruit until a particular date when the market window is offering better prices. And that firmness bump is a consumer relevant increase in firmness. So the studies generally report about 40 grams per millimetre. In this study, we've actually found a bigger increase in firmness from the GA applications we've been looking at. There were some big watch-outs in more recent studies. So they were kind of led by Matt Whiting's group up at Washington State and Todd Einhorn's group over at Oregon, where they found once they sort of got to 100 to 200 parts, there was big impacts on return bloom and economically significant impacts on return bloom where yields were really dropping off a cliff. And so early on, there was a lot of hesitancy to push beyond 30 parts per million because the reports were essentially saying in their context, they didn't find improvements above and beyond 30 parts per million rate of application. Okay. So we started off thinking, well, what can we do that's a bit different here? We can try and spread out the window in which we can apply GA and potentially have an impact. So we decided to target stage 1 cell enlargement. So this is not so modern research from 1939. It's an absolute classic that just sets out the different stages of fruit growth. We've got pre-bloom, fertilisation, stage 1, 2 and 3. And there's quite a significant phase of cell enlargement here. So we thought, well, if we can hit it with GA here, will that have a biological effect, as well as the more standard translucent green stage of application? Can we go to quite high rates and not risk poor return bloom, or is there some advantage with a certain amount of restricted return bloom, because it's like a passive crop load management effect and resulting in good sizing of fruit, potentially a benefit? And so, as I mentioned earlier, this study was on 14-year-old lapins on colt in the Derwent Valley, thanks to Wandon Valley Farm. Okay, there's a bit to take on here. I didn't actually start my, do it, no. I'm just trying to get my, oh no, hang on. Is that looking big to you, Jess? There we go.
Yeah, zoomed in.
I was just trying to get my pointer, but I don't know where, oh, there it is.
I can see a pointer now, yep.
Okay, all right. Sorry about that. Okay, so if we just look at this table, this just sets out the treatments we were using. So we had the first timing at 15 days after full bloom, or shuck fall. The second timing was 49 days after full bloom, translucent green. And then we had a treatment where we applied it at both timings, shuck fall and translucent green, and we had a control of just a water spray with a surfactant. The concentrations were 30, 50 and 80 parts per million, or 75, 115, 180 grams per hectare. So with this approach, you can see from my, I don't know what you think of this, but I thought it was a reasonable effort at some kind of graphic design to demonstrate the delay in maturity. So here we've got between the control and all the application rates at shuck fall, a 4-day delay. So there's quite a biological effect at in terms of maturity applying at that very early stage. We've got 11-day delay when we applied the medium and high rate at translucent green, and we got a 14-day delay in maturity at the high rate, translucent green, and all the rates applied both times. So it's very interesting, I think, that we've got a biological effect consistently seen in both applications. What about fruit quality? So here we have fruit size. So we didn't see, in terms of statistics, much of a difference. These last 4 treatments, so here we've got the shuck fall treatments, low, medium, high, translucent green, low, medium, high, and both application dates, low, medium, and high. So this fruit, of course, was on the tree for an extra 3 days, so it has accumulated just maybe a touch in size, but with the variability, it didn't come out significant, but I think it's real, as you'd expect. And in contrast, if we come down here to fresh weight, you can see a gradual increase as we move through those treatments. Okay, so they're more or less staying the same size, but in contrast, they're getting heavier. So they're actually getting denser. There's a higher density in this fruit. For a given fruit size, at this end of the treatment spectrum, it's going to have a higher density. Now, intuitively, I would suggest that that relates to better quality fruit. A higher density fruit is going to be packed with more goodies. It's got more substrates for respiration. It's going to have longer shelf life, and it's also going to have potentially implications for firmness for consumers. Did we get other data that backed up this quite interesting finding? Well, we did. We looked at dry matter content. So that's essentially, you take a piece of fruit, you pop the stone out of it, and you stick it in the oven. You wait before and after, you see how much dry matter is left. And you can see here exactly the same trend as we saw in the weight. So as you'd expect, the fruit for a given size is getting denser. It's got more dry matter. So it's got more structural carbohydrates in it. It's got potentially more cell wall matter, It's got more structural strength. Okay, so that's all very exciting. In contrast, stem pull, we obviously saw a treatment effect, but it was independent of timing. So we got the stems were stickier. The stems were stickier as we applied higher rates because you got a greater delay in maturity. Potentially not surprising, slightly different mechanism because this is impacting on the abscission zone where the stem is connecting to the fruit and where it disconnects at over-maturity or over-senescence. So an interesting result. Generally speaking, these are really high stem pulls anyway. It's not until we get to sort of down between 300 to 400 you start getting nervous about stems falling out in the box and things like that. Firmness. So firmness is the big one. And of course, Murphy's Law said that this was the year that our firm tech packed it in. So here we have research done with our firm tech on squash balls. You can see they're pretty happy to get squashed because that's the whole reason for being. The grape didn't fare so well. What we did was basically take our Gus penetrometer and put a great big probe, the biggest probe we had in the Gus penetrometer, and just set it to a 2 mil compression. That's the same compression distance that the firm tech applies, and called that the modified firm tech. So just for clarity, this is not measured with the firm tech this season. But what you can see is with these double applications at both the medium and high, we are getting firmer fruit that's harder to compress, takes more pressure to compress. So it's a firmer piece of fruit. Then with the penetrometer set with the small probe, and we take the skin off and we actually just penetrate the flesh to see how dense the flesh is. You can see a gradually increasing flesh firmness, which is most clear with both applications. So again, matches up with that dry matter result and the weight of fruit result. So it's all very consistent, which is nice to see, and arguably suggesting that this is better quality fruit. Some other basic measures of quality. So no real impact on sugar, and we didn't really expect it. You know, they're all the same crop load. Maybe a slight bump here at the end. This fruit was hanging on the tree for longer. So again, you'd expect a little bit more sugar trickling in over those last 3 days. This was a big one. So we're looking at the flower bud to vegetative bud ratio. So this was what sort of Matt Whiting and Todd Einhorn were saying was a big watch out. We saw a consistent drop in floral buds to vegetative buds with increased rates. But it was pretty much independent of the timing. And importantly, the double applications did not double up the effect. So we've got, sure, a drop-off, but no great catastrophic effects on yield either. So we didn't actually go back and measure yield, to be clear, but the manager at this orchard did not see any great issue with the yield in these trees. So no negative effect there of the GA applications, which kind of fits with some of the anecdotal feedback we get from growers that have played around with really high rates as well. At least on cult in Lappins in Tasmania. Okay, so just to summarise, we got some really big delays, which were quantified up to 2 weeks, particularly where both rates were applied. We had 2 weeks, and we had 2 weeks at the highest rate at translucent green. We didn't get any difference in size, but in contrast to that, we actually got increasing fruit weight, increasing dry matter and flesh firmness with increased rates and with the increased number of applications. So that peaked when we had 2 applications at the higher rates. Stem pull increased with rates irrespective of the timing, so that was pretty consistent. Firmness was highest with the rates applied at both timings, similar with these other fruit quality measures. And the flower bud to vegetative bud ratio decreased with increasing rates, but similar across timings. Okay, so on to the second study, and don't worry, it won't take me so long to get through this one. It was a bit of a simpler study. So this is down the Huon. This is at Lucaston Park, under Vaughan, self-ventilating, rain covers. Lappins on cold, about the same age. I think these are about 15 or so. So the growers in the advisory group were saying, yeah, look, we're very interested in effects of using GA under rain covers. It's a very different environment. We're trying to sort of learn how to grow under this environment, and we're concerned about increased risk of cracking, for example. Anecdotally, a lot of reports of increased nose cracking, for instance, season before last in particular. Sorry. So, can GA sort of address some of these challenges? So we went with sort of a grower standard practice, 44 parts or 100 grams per hectare, and we increased that to 200 and 300 grams per hectare, or 88 and 132 parts per million. Okay, so there was no application at Shuckfall. This was just at Translucent Green, and there were 2 applications about 7 to 10 days apart. So they were split applications. So you see here the low application was 22 and 22 and so forth, and parts per million, 50 and 50 grams per hectare. So cooler climate down in the Huon. Obviously a different season too, generally cooler season compared to the year before. We still had a 4-day delay at the low rate and significant 11-day delay at the medium and high rates. In terms of quality, we saw no real effect on diameter or size. We saw an increase of about 50 units to the Firmtech, and that was irrespective of rate. So similar across all 3 rates compared to control. We saw no increase in fruit weight, but we did see that similar trend again of increasing dry matter as we increased the rate of application, similar to the season before. In terms of cracking, so we've got here side splits, stem cracks and nose cracks. And I cracked a lot of jokes about cracking at the American conference, but no one really got it except the Kiwis and the Aussies, so never mind. The main thing was we had a technician who was a bit overzealous and loved to find nose cracks in the cherries, so he got called Crack Man, Crackhead, and Master of the Crack, that kind of thing. Anyway, the point is we've got increased levels of nose cracking, even if these are slightly exaggerated, in this particular season relative to control when we're applying GA, irrespective of rate. And Russell Fox, who is on the line and was making some comments and questions earlier, showed a really great video at one of the field days we had down here, sort of showing accumulation of moisture on the nose of the cherry, which I don't know if that was actually under rain covers or not, but that would be exacerbated under rain covers because it's a very low wind, low air movement type environment where there wouldn't be that kind of evaporation and movement of the fruit. Oh, and this just shows the kind of cracks we're talking about. So, you know, some of these would be, or many perhaps would be sold. So to summarise, we've seen delays of 4 days at grower practice and up to 11 days at the higher rates. No effects on fruit size. There was actually a slight increase in weight, so that's incorrect. Beg my pardon. Firmness improved by about 50 units, or grams per mil, in response to all rates. Dry matter cumulatively increased, and we did see an increase in nose cracks in all GA treatments. We get to evaluate the return bloom. So the summary of the summaries in the first trial in the Derwent Valley with stage 1 and 3 applications at Shuckfall and Translucent Green, up to a 14-day maturity delay, but no size effect. Definitely firmer fruit at medium and high rates with applications at both stages. Dry matter firmness increased with increasing rates and applications at both stages. Return bloom decreased with increasing rates, but was similar across all the timings. In the rain-covered trial down in the Huon, we saw higher rates having a greater impact on delaying maturity, similar to the first trial. We saw a dry matter increase with increasing rates, similar to the first trial. We saw no difference in firmness between the treatments except with the control, and nose cracking was similar across the rates under those rain covers. I think I mentioned, but we really do appreciate the support from Wandin Valley Farms and Lucaston Park Orchards. They were fantastic partners to work with. have great input into the research. Reed Fruits Enhanced Orchards were really critical in us getting the funding with Hort Innovation. We've enjoyed their support and partnership in our research over many, many years. We've got an industry advisory group of growers and agronomists that give us fantastic input and feedback. And as I mentioned, this is part of a research program funded through Hort Frontiers in Hort Innovation. That's it. Thank you.
Thank you, Dukes. And yeah, like I mentioned before, it was really exciting and a bit of a proud moment having Dugald up there representing Australia in the International Cherry Symposium. And we'll claim Claire as well. Claire Schofield, being a Kiwi, we'll claim her as Australian too. But yeah, Dugald's got some really good feedback on this presentation, but I can see a few questions as well in the chat with our growers here, Duke. So first one, do you think you would get the same maturity delay in a warmer environment, so a warmer growing region?
Well, there's speculation. I don't actually know. I'll be guessing. There's speculation that the impact of GA is actually sort of faster and more extreme under warmer climates because it's maybe metabolized faster. But I suppose a lot of those warmer climates they're going for early season, so they're often trying to keep the rates reasonably low so they don't delay fruit and miss that early season window. Anyway, short answer is I'd be pretty much guessing.
That's a good point as well. Us trying to reach that, well, I say us on mainland cherry growing regions, yeah, earlier the better. But how do we maintain that firmness? That's the question. So good one there, Ingrid. Andrew, I hope you mean this in did anyone get to taste, as in taste the fruit? I'd love to be the taste tester, but did anyone do a consumer taste test on the fruit quality of the treatments?
Not this time round, Andrew. It's a really good question. So to do a formal sort of tasting, we need to go through ethics, and it's a great big palaver. There are obviously people tasting the fruit, but without knowing, I suppose, the result before you're tasting the fruit, it's a bit hard to sort of know what you're looking for. Yeah, so unfortunately, no. But that's an interesting question and something we could consider. We've got a season to go, so and we are keen to see if we can repeat that treatment of stage one, the early and the later application. So if people care enough on that advisory committee, and then we could be probably convinced. I just wouldn't want to have too much to do with the ethics application because I'm just too old and grumpy for it.
I feel your pain with ethics, hey? From Russell, is dry matter a better maturity fruit quality indicator than just bricks or firmness?
Gee, I would say, I mean, I think firmness is probably the best indicator because once the fruit's overripe, you start losing firmness. Whereas with sugars, there's all the vagaries of crop load, the season, age of the tree, variety, all sorts of things. Dry matter, I think, definitely impacts quality. It's a bit of a pain to measure. So I don't know if we'd sort of be routinely measuring it, because you could simply just size it and weigh it and look at that ratio, as a indicator, as a proxy for dry matter. So it'd be much quicker and easier doing that on some fruit than having to dry them out in an oven. Yeah, but dry matter, I think, as I said in the conference, the Kiwis have been looking at dry matter in apples and kiwi fruit for a long time, but obviously that's related to starch reserves. There's no starch in cherries, of course.
I've noticed, everyone, we've just ticked over 8, but if we're all happy to stay on for maybe just another quick 5 minutes while we finish off these last questions. The early and self-pollinating varieties, has there been any work with GA timing on flower bud initiation to reduce flowers for the following season? So I'm assuming that's for like crop load management, Russell.
Not by us, Russell, but some of those American studies did observe a delay in flowering at the high GA applications. So it makes intuitive sense, but they did actually look at flowering dates and compare them across the treatments, and the higher GA treatments were delaying flowering. Yes, but we didn't look at that.
And any work done on the 7 to 10 days out of harvest to firm up fruit using growth hormones?
We haven't. It's certainly standard grower practice. I think the various companies have done that and shown there is benefit for sure. But that's all about the firmness. It's not about the delay.
Yeah. And last one, Dukes, could combining G applications with amino acids such as glycine, betaine, I can't say that,
Betaine, yeah.
calcium and silicon give a further benefits towards improving fruit firmness post-harvest in addition to reducing cracking?
Oof. So look, Claire's very focused. Claire Schofield is doing her PhD on sort of calcium uptake and fruit quality, and there's some interesting results coming from her study showing some correlation with firmness and increased calcium, but there is quite a bit of variability and noise in the data, although it's statistically significant. It's important, I think, to note that calcium is an immobile nutrient, so you can't get it in late in the stage of in the fruit stages after about, I don't know, 45 days after full bloom. So you need to get it in early. There's lots of talk of the benefits of calcium sprays and different opinions. Lee Cowsitz from Washington State Uni worked out that about 0.001% of calcium actually gets into the fruit that you spray on. But then Nocky, the cracking master expert in Germany, has got his unzipping hypothesis of what leads to fruit cracking, where they get micro cracks. And he's theorized, or I don't know if he's actually shown experimental evidence or not yet, but when you apply calcium, it could prevent that zip from unzipping, to get the analogy. So there's a micro crack, and when that unzips, that leads to a macro crack, and calcium could prevent that unzipping. So I'm not, off the top of my head, I'm not certain he's experimentally demonstrated that, but that was certainly his hypothesis, and he's the world-leading expert there. So the thing with silicon is, I think it's a problem if you've got old depleted soils and there's a lack of silicon. I think it is actually a plant nutrient, because that was debatable for a long time. But other than in grasses and things like that seem to depend on it for some structural strength, I'm not that familiar with silicon providing lots of benefits, or not that familiar with it actually being deficient. But look, there'll be people on the line that know more about that kind of stuff than me, that have worked in plant nutrition for a long time. But there's some interesting questions for sure. Glycine betaine, that's like a osmoprotectant. That's like, it's a compatible solute. So it's generally, sprayed for stress situations, try and prevent effects of frost and drought and things like that. Certainly in crops, annual crops where they breed them, those osmolytes, those things like betaines, certainly provide resilience and resistance against stress, and it's probably a future. There's probably a big future in that, but I don't know how much difference it makes applying it, except in reactive situations. I think most of the time that's going to be internal, genetically determined through breeding.
Thanks, Dukes. All right, guys, the questions tonight running hot. Thank you, both Edwina and Dugald, for persevering and coming on tonight. It was Absolutely great to listen to you both. And thank you everyone for the questions tonight. That makes these webinars a lot more interactive, and maybe something that you're thinking of, someone else is thinking. So it's great to always ask them while you can. I'm sure Dougal and Edwina would be more than happy if you wanted to reach out and ask any further questions about either of their presentations. You're more than welcome to. We will have Edwina join us in Young for our in-person workshops, all about cherry nutrition. So jump down to the bottom of my slide there. We've got our 2 in-person cherry nutrition workshops run by the Extension Project. One on the 31st of July in Young, and that's 10 till 12:30 at the Young Service Club. And then on the 7th of August in Shepparton from 9 till 11:30 at the Fruit Growers Vic offices. You can go on that QR code and register for all of them. My Tassie listeners, we were going to do a nutrition workshop, but Sam Smee's already got his nutrition workshop happening, and rather than reinvent the wheel, we're all part of the same industry. So I really encourage you to go along to Sam's, which is on the week after the Shepparton workshop on the Wednesday. So those Tassie guys, make sure you're heading to Sam's. And our South Australian listeners, we'll have one for you guys in November. So keep your eyes peeled on the industry website for that as well. But I hope everyone joins us next Wednesday night for our last webinar. I'll be sad not having everyone on a Wednesday night, but on the 23rd of July at 7 p.m, we're finishing off this series with getting those 1%ers right for the 25-26 season. And so we'll be listening to Dave Hughes from Ag Nova and a lot of their research they've done on some of their different products that they've got as part of the Ag Nova suite. And I also managed to track down Bruce Scott from Newers, who was recommended by actually a few people that I spoke to when we're pulling these webinars together. And Bruce is going to talk all about your testing, those little 1%ers that you can do throughout the season to have the most impact on your crop. So again, a massive thank you to Dougal and Edwina for jumping on tonight. It's like we said, I'm getting paid for being here, but everyone else is doing it on their own time. So really appreciate them coming along tonight. And again, as always, a big thanks to Geets behind the scenes here, making sure that we all work well. So enjoy your night, guys. Thanks again for joining me. And I hope you all can sign up for the last webinar next week at the same time. We'll see you all shortly.